Good morning. Good morning to all of you. Today I have some important question of chemistry which is earlier asked in 12th examination, 12th CBSE examination or any other examination on which we are going to deal, on which we are going to learn that how the question can be solved. So let's start with the first question. Okay, so here you can see since we have not the good camera and we can see, so we have some questions over here. So the first question is that we can say the first question is saying that the oxidation state of iodine in H4IO6. Okay, so first of all we have to find the oxidation state of H4IO6. Okay, so this H4IO6 negative charge, it is in hydrates form. It is in hydrates form. That is usually it can be written as 2 mole of H2O. Okay, and iO4 minus dot. That means it have two crystal of water molecule attached as a water of crystallization in their compound form. So we have to find the oxidation state of I in that. So since iO4 minus dot 2H2O, since 2H2O is a neutral, it is a neutral. So mainly we have to find the oxidation state of I in iO4 minus. So what we can say, consider the oxidation state of I is X. So X, and we know that the oxidation state of oxygen is -2. Since there is 4 oxygen atom over here, so we have just multiplied by 4, and the total that there is one negative charge over there, so it is equals to 1. So X minus 8 equals to -1. So X equals how much? Equals what? It is equals to -1 plus 8, that means X equals 7. Okay, so the which is the right answer? That is the right answer. Now let's move to the next question. Next question says that which of the following compound will undergo self-aldol conditions. So we have to know first that what is the meaning of self-aldol condensation. Those species we can themselves can undergo aldol condensation reaction is known as self-aldol condensation. And the necessary condition for self-aldol condensation is presence of alpha hydrogen. Okay, so in that case, in first option we have what? C bond, that is C6H5 bond CHO. Since this is the function group, so after that, if the function group have attached carbon having any hydrogen, this hydrogen is known as alpha hydrogen. That means after the function group, the carbon having hydrogen is known as what? Alpha hydrogen. So since we can see here that here hydrogen is present, here hydrogen is present, all the position have hydrogen in case of phenyl ring, but in that carbon there is no kind of hydrogen, so we can say there is no alpha hydrogen, so this option will be wrong. Similarly, in case of that one, we can see that in that case also this is wrong because that answer is not good. Now C2H5OH, for this we can say that C2H5CHO, it has CS3 bond CS2 bond CHO. That means it have, this is a functional group. Along with this having the 2 alpha hydrogen. So if a aldehyde or ketone having alpha hydrogen, then that can show self-aldol condensation. So we can say that this can be show self-aldol condensation. That cannot be shown because there is no kind of alpha hydrogen is there, and this can also it is the aldehyde, and along with it have one alpha hydrogen, we can say that, but it having the functional group, so the better option is that one. Okay, now we are going to the next question. say that question is saying that the active species in the nitrogen of benzene is. So what we can say, what is nitrogen? The introduction of nitro group on benzene ring, okay, is called nitrogen. And for nitrogen we need a nitrating mixture of HNO3 and H2SO4. It will give H2SO4. After reacting, it just introduce NO2 in hydrogen in benzene ring. This is known as nitrogen of benzene. So what we can say, how this nitro group come across. So we can say when this nitrating mixture, that is called mixture of H2SO4 and HNO3 reacted, so it will form NO2 positive, which is an electrophile, means generation of electrophile is here, and H2O and HSO4 minus is there. So this NO2 plus is forming by the help of nitrating mixture. So the active species in the nitrogen of benzene, that means this is going to react. So active species will be NO2 plus. So the right answer is A. Now the next question is, the ion with that is isoelectronic with CO. Since CO having 6 plus, that is 14 electron, and this is O2, this is the first option is O2, second option is O2 plus, third is N2 plus, and the next is Cn minus. So in case of O2 we have 16 electrons, we know. In case of O2 plus 16 minus 1, that is 15 electron is there. In case of N2 plus, what we have 7 plus 7 minus 1 equals to 13 electron. In case of Cn minus, what we have 6 plus 7, since 1 electron is added, so plus 1 is equals to 6 plus 7 plus 1 equals to how much? This is 14 electron. So we can say that 14 electron having Cn minus and CO, so the isoelectronic is Cn minus. Now the next question is that according to the Raoult's law, the relative lowering of vapor pressure for a solute is equal to. So according to Raoult's law, we know that the relative lowering of vapor pressure, that is P naught minus P by P naught, is proportional to mole fraction of solute. So it is proportional to mole fraction of solute. We know that is equals to P naught minus P by P naught is equals to mole fraction of mole of solute by total mole, Na plus Nb. So what we can say, the according to Raoult's law, relative lowering of vapor pressure is equals to what? Mole fraction of solvent, wrong answer. Mole of solute, wrong answer. Mole of solvent, wrong answer. Mole fraction of solute is the right answer. Now the next question is saying that the equilibrium constant for a reaction of N2 plus 3H2 gives 2 mole of NH3 is K. Then the equilibrium constant for the reaction NH3 gives half mole of N2 plus 3 by 2 mole of H2 is. What we can say that if a reaction is N2 plus 3H2 gives reversibly 2 mole of NH3. So the rate constant K will be what? Concentration of NH3 to the power 2 upon concentration of N2 to the power 1, because it have 1 mole. Concentration of H2 to the power 3. Okay. And in case of, this is equals to K, question number 1. And in case of NH3 gives reversibly half mole of N2 plus 3 by 2 mole of H2, what we have? We can say that rate constant K equals to concentration of N2 to the power half into concentration of H2 to the power half and upon concentration of NH3, because the rate constant K equals to concentration of product upon concentration of reactant. Okay, with their moles can be written as at coefficient, means we can say that the stoichiometric coefficient is written as a power in case of in the expression of rate constant. So we have K dash equals to this much for that second reaction. So K dash square will be equals to N2 to the power 1 into H2 to the power 1 upon NH3 to the power 2. So what we can say? We can say that K dash equals to this much. So half of K dash, half of what? K dash will be 50. So we can say that the K dash equals to this much. If K dash equals to this much, so we can say 1 upon K dash will be equals to what? Means if it take the root of this, so it will be equals to root of K equals to root of K will be equals to S3 to the power 1 and N2 and H2 to the power 3 by 2, and this is for 1 by 2. So 1 by root K will be equals to, since it is reciprocal, so it will also be reciprocal, what we can say, N2 to the power half H2 to the power 3 by 2 by, and H3 to the power 1 by, sorry, nothing. So this is equals to 1 by root K, and this K dash equals to this much. Since this is equals to this is, so K dash must be equals to 1 by root K. So it is question asking that the new equilibrium constant for the new reaction is equals to what in terms of K. So in terms of K it will be 1 by root K. This is the answer. Now the next question is, which of the following will be most easily attacked by the electrophile? So in that case we have chlorobenzene, we have benzene, we have a nitrobenzene, we have a toluene. So in case of toluene we are seeing that in case of toluene there is a CH3, and CH3 is an activating group for electrophilic reaction. So since there is CH3 attached, so it activates the electrophilic substitution reaction. So we can say that the most easily attacked by the electrophile will be benzene to the power bonded with CH3. So that is the right answer. So this is not the right answer for electrophile. Most easily electrophile will be only toluene. Number of atoms in 4.25 gram of NH3 is, next question is saying that first of all 1 in 10 power 23, 2 in 10 power 23, and 4 in 10 power 23, and 6 in 10 power 23. We know that if anything in gram molecular mass, so it has Avogadro Sankhya number of molecules. So we can see that since ammonia has 17 gram as gram molecular mass, if this much is there, so it contains 6.022 into 10 power 23 molecule of ammonia. But if you take how much atom is there, so since one molecule of ammonia has 4 atoms, so total atom equals to 4 into 6.022 into 10 power 23 atom. Okay, for 17 gram. So for 1 gram it is equals to 4 into 6.022 into 10 power 23 upon 17. Okay, and for 4.25 gram you can say it equals to 4 into 4.25 gram into 6.022 into 10 power 23 divided by 17. Since after cutting this to that it equals to 4.25, and 4.25 can be cancelled with 4.25 gram is cancelled to a gram. So we have 6.02 gram 10 power 23 atoms in case of 4.25 gram of ammonia is there. So the right answer will be this one, B. Now gamoxine is next question is saying gamoxine is what? Is it chlorobenzene? Is it bromobenzene? Is it carbonyl chloride benzene? It is C6H6Cl6. Yes, it is C6H6Cl6. That is carbon hexachloride is known as gamoxine. It is also known as 6,6. It is also known as 6,6 compound. Okay. So this is there. The structure of gamoxine is like that. This is the benzene. This is your benzene. And all the places have hydrogen. Sorry. There is no kind of bending here. This is the Cl H H Cl H Cl H Cl H Cl H Cl. This is the structure of bending which we have written. Now the next question is saying that nylon is what? Is it polyester? Is it polyamide? Is it polythene? It is polypropylene. So nylon is a polymer of what? Nylon 66 and nylon both are polymer of amide. So the right answer is polyamide. No polyester, no polythene, and no polypropylene. Okay, the right answer is polyamide. The right answer is C. The next question is nitrobenzene or nitrogen mainly give. Nitrobenzene and nitrogen mainly give. Okay, yes. In case of nitrobenzene, this is the nitrobenzene, and have the nitrous center, that means NO2 plus going to be reacted. So since the nitro group is deactivating at earth and para position for the electrical substitution reaction, so we can say that it deactivates that and that position. So this an electrophile is going to reach at meta position. The right answer is what? NO2 and NO2. This is right answer. So what is the answer? This is the meta dinitrobenzene. That is the right answer. Now the next question is, which of the following is the strongest acid? Okay, formic acid, acetic acid, propylene acid, and stearic acid. Since we know that formic acid is HCOOH, acetic acid is CH3COOH, propylenic acid is CH3CH2 COOH, and the stearic acid is CH3 power CH 2 to the power 14 bond COOH. This is stearic acid. And on increasing the number of alkyl group, the stabilization of carboxylic ion is decreases. So this have the carboxylic ion less stable, and this is the more stable, and this is the more, and the maximum stable carboxylic acid after dissociation of H plus ion will be this in case of formic acid. So the formic acid is the most strong acid among all the species. Now the organic rubber is what? Okay, the organic rubber is what the question is there. So you can say the option is phosphonitric chloride, silicon liquid, silicon grease, and silicon resins. So the organic rubber is that means P. Organic rubber is PnCl2 to the power x. It may be PnCl2 to the power 2, PnCl2 to the power 3, PnCl2 to the power 4, and so on. So what is there? There is a phosphorus nitrile chloride. The right answer is E. Now the next question is there. It is asking that the anodic oxidation of electrolysis of ice cold H2SO4 between the electrode at high current density gives. So see the 50% H2SO4. Okay. So at anode we know that at cathode there will be reduction, and at anode there will be a oxidation always. So knowing that we can say that at the end